Hello everyone, we will solve this today's LeetCode problem. So the question is delete nodes from linked list present in array. So it's a medium one, but believe me, this is not a medium one. It's an easy problem. If you have solved delete node from a linked list, a single node, you will easily solve this problem, right? So let's see what the question is asking. So we have given an array of integer nums and the head of the linked list. Return the head of the modified linked list after removing all nodes from the linked list that have a value that exists in nums. So basically we have given an array nums, right? And there are some values which is present, integers values which is present, and we need to remove all these values which is present in nums. If it is present in linked list, then we need to remove all these values from the linked list as well, right? If the same values are present in the linked list, then we need to remove that one, right? So basically, if suppose I'm making this as an array, but this is a linked list, right? So if suppose this is an this linked list is given like this: 1 2 3 1 2 3 1 2 3, or like this 4 1 4, right? This is something like 5. So what do we need to delete, right? If 1 2 3 is present, so we need to delete all the ones from linked list, right? This one will also delete, this one will also delete, this 2 will also delete, this 2 will also delete, this 3 will also delete, 4 and 5 will only be remain, right? So basically, if you see that this one will remove, 2 will be removed, 3 will also remove, so basically it will be left with 4 and 5, right? This will be the linked list, the final linked list you will return the head of linked list. This will be the remaining linked list you will be formed, right? That's what happening. So nums array is here 1 to 3, linked list is here, so 4 5 will be remaining, right? So that's what the question is asking. Just now the question is just how will you delete the linked list, right? Delete a node from the linked list. So basically, if you see uh, that you can definitely delete a node from the linked list uh, uh, by simply, if you have solved the questions like that, you can simply delete that, right? You can simply delete that. So it's just a delete a node in a linked list. So when we say that, how will you delete that? So suppose this is given like 1 2 3. So how do you delete? Suppose I need to delete this 2 1, right? This 2. So this one, if you want to delete this 2, you need to change this one next value to 3, right? You change this to 1 to, and just delete this 2 value. So you are successfully able to delete it. So for that, how will you so for that you need to know the previous values of the for the current one, and the next value also, right? So basically three you need three pointers. Let's take a pointers, right? The previous one, the current one, and the next one, right? This three things you need, of course, right? So the previous one will denote to this. Let's make some spaces. This current one will be like this, and this is the next one, right? So this will be look like this, right? So what will you do for removing this current? You need to just change this previous next to this next one, right? You just need to change the previous next to this current next, right? right right, and just delete the current one. And this will be successfully goes and on, goes on and on, right? And if the next number is 4, and so how will this determine? So the previous next is current next, so this 2 is removed already, right? And now this current needs to be at 3. So that's why you need a next value that will store this current next in previous, such that you will just change this current value to next. And if this node is deleted, this previous will be the same, because this node is deleted, and this 3 its previous will be this, like this, right? Like this, right? So previous will be deleted, but if this node is not deleted, then previous will change to the current one, right? The previous, if node is not deleted, if node is deleted if node is not deleted node is not deleted, then the previous one will be is equals to current, right? It will be the before changing the current value, right? Otherwise, if node is deleted, the previous one will be the same value, right? So that's how this getting this will be solved, right? This will be solved. Now this is for middle one, right? This is for the middle one. But what when we need to delete the head, right? What we need to delete the head? Suppose I need to delete head. I need to delete this head. So what three pointers we know, right? The current one, the current one, which is this only. The next one we know. But how do we know the previous one? So we need to make a previous node such that I can simply, if the one node, the first node head node is needs to be deleted, so such that I can uh, point this previous one to the next point, right? So we need to make a dummy node beforehand with the value -1 or something. You can make any so -1 why I'm taking, because all the numbers are positive, right? All the numbers are positive, so I taking the -1 value, which is representing the previous one, right? And ultimately what I will return the dummy connects value, right? This will be more clear when I simply uh, implement it, right? So this is for deleting node, right? And how we will know that which node will be deleted? So that will determine by this nums value, right? That will determine by this nums value. So we will store this nums value in hash table and check, right? So let's just implement it, because this is an easy problem. So this is unordered map, and this is int, and this is map. So let's just store the values of nums in map. So for that, mpx plus plus. Now I need to make a dummy node, right? I need to make a dummy node which will represent a -1, because I need to know that from where I need to return it, right? Also, I also need to make a previous one which represent null value, right? Also, I need to make a list node temp which will represent this dummy, and this temp will temp will point to this head value, right? This will represent the head value, right? And this previous will represent what? This previous will determine this dummy node, right? This previous will determine the dummy node. So what I will do, I will just, is if the temp next is representing head, so I will do what? Previous is equals to the temp value, and temp will move to its next value. This is what we can do. Now I will iterate in this temp, right? I'm not doing anything with this head. I'm just making an extra node for this temp, which pointing to this head, and I'm just starting from the temp value, which is now representing head, and this previous is representing this temp, right? The previous is the previous one. So now what I will do, I will check for temp ka value. So we have started from our head. This temp is now representing head, because temp ka next is head, right? So if mp map has this value, if this contains a map, it means we need to delete this node further, right? So for that, what we do, we will point the previous one, the previous next to current next, right? So for that, I also need to store the next part of the current node, right? So this will be, so you can also take as this current if you are confused, but that will be the same, right? That will be gonna same, right? Let's take this current, right? So the next one will be the current next, right? If amp count value is available, so I need to delete this current node. So for that, what I will do, I will point this previous next to current next, right? Or you can write it like this next also, right? So depends on your implementation, what you like, right? All, and I delete this previous, sorry, this current, right? Because we need to delete this current value. So I pointed previous next to current next and delete the current node simply, right? Okay. Else, do I need to change previous also? No, I don't need to change previous, because I have deleted the current node. So the next number which will be coming for the next number, the previous one previous node will be the same previous one, so I don't need to change the previous. But what if the node is not deleted? So I need to change the previous to current one, because node is changes. So we will shift this previous current next to the next step, right? This will be shifted to next step if node is not deleted, right? So previous will be shifted to current, and this current will now switch to next file, right? That's why we need to, because ultimately it needs to shift to forward now. So that's why current shifted to next, but before I will change previous to current if node is not deleted, right? And simply what we will return after that, right? So this dummy which is current is representing its its dummy connects representing head. But if head is already related, then the something will be go in place of here, right? So that would be always dummy ka next value, right? So we will return dummy ka next value, right? Because dummy value is not manipulated, right? Dummy node is not manipulated. So we will just change this to okay. And also this will be not temp, this will be the current, right? This will be the current value, right? So this is how we solve this problem, basically. So let's run this and see what we have done. Okay, we have done something wrong. Okay, this will be the current value. Let's run again. Okay, so okay, nothing, just a compilation error. Logic should be correct, right? We have successfully passed the sample case. Let's submit it. We have passed all the test cases, right? So basically it is just like that. You have delete a simple node, but before that you just need to check that whether this value is present in map or not, right? If any of the values one is present, then you will delete all the ones from the linked list, right? That's what this is representing. Now the space and the time complexities. So the time complexity is, so if you see, we need to uh, we need to iterate in whole nums. So O of n. Also we need to iterate in whole of linked list. So O of m. So that would be O of n plus O of m, right? And the space complexity. So we have taken an extra unordered map for storing all the linked lists. So that would be going for number of distinct numbers present in nums, and that can go to 10 to the power 5, right? So that would always also O of n. Although we have also taken 2 3 variables, but that are variables, so that is O of 1 only, and we are not using any extra linked list node. So we have not done it. So that will be O of n, can be go O of n. Basically, if I'm thinking of that, if all the numbers are distinct in present in this nums array, right? So n is the length of nums array, and m is the length of linked list, right? If I think of all the numbers present in the nums is in the worst case are distinct, so it will take O of n in the worst case, right? So this is how the time and the space complexity will be there. Hope you understand it. Thank you.